Welcome to today's video. Today we're going to be focusing on adding and subtracting radicals. We're going to show that mastery in class by scoring at least a 70% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet and we'll get you a fresh copy tomorrow. Now, when it comes to adding and subtracting radicals, we're not going to have variables, but we are going to have coefficients and numbers underneath the radicand. Our first step is going to be to simplify each term to simplest radical form. So we don't want anything extra underneath that square root symbol or the cube root symbol. We want to make sure everything is pulled out. And just as a reminder, you put the circled pairs or triplets on the outside and the non-circled pairs or triplets on the inside. Excuse me. Once we do that, you're going to combine any terms that have the same number under the radical symbol. So if I look at example problem number 1, if you notice, we have 5 times the square root of 11 minus 7 times the square root of 11. Since the numbers underneath the radical symbol are the same, these are going to be considered like terms. So we're going to do our coefficients. 5 minus 7 gives me negative 2, and we're going to keep the square root of 11. We're treating the square root of 11 like it is a variable. We don't combine x and x and say it's x squared, or 2x, or x plus x. You would say 2x. In this case, it's the square root of 11, so 5 minus 7 gives me negative 2, and we keep the square root of 11 there. Now, if we look at our second example, we have 7 times the square root of 2 minus 2 times the square root of 8. Well, 7 times the square root of 2 is already completely simplified, but the square root of 8 is not. So I'm going to break it down just like we did before. I know I'm circling pairs because it's a square root. So the square root of 8 is 2 times the square root of 2, but I can't forget about my extra coefficient here. So this is going to become 2 times 2 times the square root of 2, which gives me 4 square root of 2. So now I'm just going to rewrite my problem. I have 7 square root of 2 minus, and in this case it became 4 times the square root of 2. Well, if we look, our numbers underneath our radicand are the same, so now we are just going to combine our coefficients. Well, 7 minus 4 gives me 3, and they're both square root of 2, so it is 3 times the square root of 2 as our final answer. And if you were to use either Desmos calculator or the handheld calculator and type these answers in, you can type the initial problem 7 square root of 2 minus 2 square root of 8 in. You're going to get a decimal. But then on the next line, type 3 times the square root of 2 in. Your decimals should match each other. If we look at example 3, 4 times the square root of 2 is already simplified. 6 times the square root of 7 is already simplified, but I need to simplify the square root of 847. That breaks to 7 and 121. From there, 121 is 11 and 11. I know I'm circling pairs because it's a square root. So the square root of 847 is equivalent to 11 times the square root of 7. So now I'm just going to rewrite my problem. 4 times the square root of 2 plus 6 times the square root of 7 minus 11 square root of 7. If you notice, all the numbers underneath the radical signs are not the same. The only ones that are the last two terms. So we're only going to combine the coefficients on those two terms. Well, 6 minus 11 gives me negative 5 square root of 7. And I'm just going to bring down my positive 4 times the square root of 2. There's nothing you can combine it with, so it just stays a separate term. So my final answer is actually a problem. And that's okay, because there's nothing else we can combine. Example 4. We need to break down all of these. None of them are in simplest form. So if I start with the 8, I have 3 times 2 times the square root of 2, which becomes 6 square root of 2. If I break down 125, I have 25 and 5. So, and it's not going to be plus, it's going to be minus 5 times the square root of 5. If I break down 32, So in this case, it is plus 4 times the square root of 2. And my last one, okay, so if we look now that we have broken down everything, now we can combine any like terms we have. So if I look, I have to look at what's underneath the radical symbol. I can combine my red and my blue, or 6 times the square root of 2 plus 4 times the square root of 2. That gives me 10 times the square root of 2. And then I'm also going to combine my negative 5 times the square root of 5 plus 3 times the square root of 5, which gives me negative 2 square root of 5. And you can tell you are done with the problem because our numbers underneath the radicals are not the same, but they are completely simplified down. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.